How does bandwidth affect modulation techniques? Imagine trying to send a message through a narrow pipe versus a wide one. The size of that pipe, or bandwidth, really influences how you can send signals and how well they arrive. Bandwidth is the range of frequencies a signal takes up, and it plays a big role in how modulation works in electrical engineering. When you change the way you encode information onto a carrier wave, bandwidth becomes a key factor. In analog modulation, like amplitude modulation, the bandwidth needed is twice the highest frequency of the original signal. That means if your base signal has a high frequency, your modulated signal needs even more space in the spectrum. For frequency modulation and phase modulation, the bandwidth depends on how much you shift the frequency or phase. The more you shift, the wider the bandwidth becomes. This is because larger shifts can cause the spectrum to spread out more, which can lead to interference if the bandwidth is limited. When it comes to digital modulation, things get a bit more technical but still straightforward. Digital signals encode bits onto carriers using symbols. The speed at which these symbols change, called the symbol rate, determines the minimum bandwidth needed. Faster symbol rates mean more bandwidth is required. To make better use of limited spectrum, engineers use more efficient schemes like quadrature phase shift keying. This method sends 2 bits per symbol, doubling the data transmitted for the same bandwidth compared to simpler schemes. But, as you increase the number of symbols, the signals get closer together, making it harder for the receiver to tell them apart, especially in noisy environments. There are always trade-offs. Using higher-order modulation schemes allows more data to be sent over less bandwidth, which is great when spectrum is scarce. But it also makes the system more sensitive to noise and interference, increasing the chance of errors. This is why system designers carefully choose the right modulation scheme based on the available bandwidth and the quality of the communication channel. In modern systems like cellular networks, bandwidth management is essential. Engineers often adapt the modulation scheme dynamically depending on the channel conditions to keep data flowing smoothly. They also design filters and signal processing blocks to keep the signals clean and prevent interference. So, in essence, bandwidth shapes what modulation techniques can do and how well they perform. Using the right modulation scheme for the available bandwidth helps ensure reliable, high-speed communication.